Hello and welcome to the second sequence of correlation analysis. In the previous video, you have learned about the basic concept of correlation by its definition, and you've also learned how to interpret the magnitude and direction of correlation between the two variables. Also, we have talked about the two methods of calculating correlation coefficient. First is by scatter diagram method and the second one is by Karl Pearson's coefficient of correlation. Now in this video, we'll be talking about Spearman's rank correlation method. As the name suggests, this method was proposed by Charles Edward Spearman. He was a British psychologist and he proposed this method in 1904. Now what's the use of Spearman's rank correlation? Not all the relationships are quantitative in nature. There are certain relationships which are of qualitative characteristic. You talk about your performance, you talk about your beauty, you talk about honesty. There are certain things which are not absolute, but they can be established in comparison to one another. Therefore, for qualitative relationships, for qualitative correlationships between variables, we make use of Spearman's rank correlation. Now, we calculate Spearman's rank correlation by using this formula, which you are seeing on the screen. It is R is equal to 1 minus 6 summation d square divided by n bracket n square minus 1, where R denotes the correlation coefficient as per Spearman's. There is a slight differentiation between Karl Pearson coefficient of correlation and Spearman's rank correlation. We denote it with the symbol RS. S is written in the foot as a different connotation of correlation coefficient. D is nothing but the difference of ranks or the grades which are given to the variables. N in the denominator is the number of observation, paired observation, which we are correlating in the data. Now let's talk about computation of rank correlation. Spearman's rank correlation, as you can see, it is denoted by RS, is calculated. There will be three kinds of situations that you will be seeing in the question. The first one, when the actual ranks will be given to you in the question or in the situation. Certain times you will not find the ranks given, but you will find the grades given or the marks or evaluation of some criteria which has been there to measure the attribute is given to you in the question, and they'll be quantified. So you'll see the grading in that and you have to rank that. And the third category of situation that you will face is ranks are not given, so you have to rank them first. Grades are given, the grades are repetitive in nature. So these are the three situations that we are going to handle in this video. So when the ranks are given to you in the question, the task is half done. All you have to do is construct the column D, which is difference of rank, which is given in the question. Now the task in this category is when the ranks are not assigned in the question. You will be given grades and you are supposed to assign the ranks to the variable. The ranking is done in a usual manner, either from the highest value as marked as 1 and the lowest value marked as the maximum rank, or vice versa, means the lowest value marked as 1 and then proceeding further. To elaborate more, let's begin with the first category when the ranks are already given to you in the question. Here is an example for you to show when the ranks are given how you are going to compute Spearman's rank correlation. Now in this question, the data gives you rank of A and rank of B. They are clearly given to you and there are 10 pairs of observation there in front of you. So here we go. We simply construct column D, which is nothing but rank of A minus rank of B. Here we see certain positive values and certain negative value. Consequently, since you have to use the value of d square in the formula, so you have constructed a second column which is d squared. You are simply squaring the rank value which you have just calculated. Towards the end, you have calculated the summation of d square values in the bottom of the table. After calculating the value of summation d square, let us simply substitute the values in the formula. The formula is 1 minus 6 summation d square. The value of d square that we have computed here is 80 divided by n bracket n square minus 1, where you have been given n is equal to 10. There are 10 pair of observations given in the question. So you have the value of Spearman's correlation coming out to be 0.515 plus. This is a positive value. So from this, your interpretation is that there is a moderate degree of correlation, positive correlation between A and B. Now let's move on to the second category where the ranking is not given but the grades are given to you. Variable values in terms of their grading is given to you for a certain pair of values. Let's see how do we proceed about that. So here you have two values x and y, two variables x and y, and there are certain valuations are given in a pair of 10 observation. So here in this question, you can see 10 pair of values for variable x and y. And if you observe carefully, in the column x, you find 35 as the highest value of variable x. So let's assign rank 1 to this value of variable x and label this column as Rx, which indicates the ranks for variable x. Now observing the second column, which is the variable values of y, and we'll assign the rank. Carefully observe it, you'll find 25 as the highest value of variable y, and consequently rank 1 will be assigned to this value. As you can see, you have done nothing but you have assigned rank from 1 to 10 to variable x and variable y. There is no repetition of value in variable x and in variable y, so ranks are unique in nature. Now we'll do what we have done in the previous question. We'll calculate the value of d, which is nothing but the difference of rank of x and y. Now the next column that we are constructing out of it is value of d square. We are simply squaring the difference of values of rank in the column. And towards the end, the value of summation d square is coming out to be 112. Now let's calculate the value of Spearman's rank correlation by simply substituting the values which we have calculated just now in the table. We have Spearman's rank correlation value as 1 minus 6 into summation d square, which is 112, divided by, there are 10 pair of values, so 10 into bracket 10 square minus 1. As a result, the value of R is coming out to be 0.32. which indicates a low degree of correlation between the two variables. I hope the concept of ranking is clear to all of you. So let's proceed with the second and the final category of Spearman's rank correlation question. And here you will find the values of grades to be repeating in the series given to you. The question that you are seeing here, you can see variable x and variable y series. Here in variable x series, you can locate that 27 is the value which is repeating 3 times in the series x. And for series y, if you see carefully, it is 38 which is repeating how many times? 3 times again. So let's see how this repetition is to be ranked and it is to be treated in the formula of rank correlation. We learned the method of average ranking for ranking the variables where the rank is repeating. So for developing the rank x column, as we can see that the highest value in the series is 35. So we have labeled it as 1. But if we observe it carefully, that 27 is the next variable, highest variable in the series x, and it is repeating 3 times. So if we go by sequentially ranking these 27, we are going to allocate rank 2, 3 and 4. Whichever 27 you want to allocate. So we are going to allocate 2, 3 and 4 rank to 27. Now in average ranking method, what we are going to do, we are going to combine these 3 ranks and take an average of it. That means rank 2 plus 3 plus 4, how many times it is repeating? 3 times. So divided by 3. This is how you calculate the average. Sum of values divided by number of such values. So second plus third plus fourth rank divided by 3 will give you the average rank to be 3. So if you see, we have allocated 2 and 4 have disappeared from the ranking, and it is 3 which is appearing in front of 27 wherever it is coming in the series, right? So from 4 onwards, we will allocate the values to the variables which are less than 27 in the series. So if you see, it is rank 1 associated with 35, rank 3 which has absorbed rank 2 and rank 4, and 3 is mentioned in front of 27. From there we find that rank 5 goes to 25, so on and so forth. Now we'll do the ranking for Y series, where 38 is again repeating for the 3 times. We are going to see what all ranks are going to be assigned to 38 3 times, and then we are going to take the average. Let's begin with ranking of column Y. 50 is the highest value, so you can see rank 1 is assigned to 50. After that you have 41. After 41, you can see 40 is there, so rank 3 is assigned to it, and after that the next number comes is 38. So which rank goes for 38? It is rank 4, 5 and 6. Now take the average of it. 4 plus 5 plus 6 divided by 3 again. You will get the average rank to be 5. Allocate 5 to all the 38 which are present in the series. So you can see 5 written in front of 38, all the values of 38 in the series Y. So what all values of rank got absorbed with 38? It is 4, 5 and 6. So they are gone with 38. and they have turned into an average value of 5. So you can see that the next number after 38 is ranked 7. Which number is that? It is 36, which is labeled as 7th rank, and we have continued with the rest of the numbers. So this is what we have learned about ranking the variables when the values are repeating, when the ranks are repeating. What we have done, we have learned the method of averaging the rank for the repetitive variables. Next you can see we have constructed column D, which is nothing but Rx minus Ry. The values are calculated, and subsequently the value of D square is calculated in the next column. The total of all the D square is coming out to be 28. Now here we have to put the effect of these repetitions into the formula that we were using so far, that is 1 minus 6 summation D square upon n square minus 1 into n. Now what we are going to do with the repetition? Here it is in front of you. We have denoted the repetitions by T. T is the number of times the values are repeating in both the series, that is x and y. T is calculated as 1 by 12 bracket m cube minus m. Now this m is nothing but the number of times a particular variable is repeating in a particular series. Like in series x, 27 was repeating 3 times, so we will take value of m for series x to be 3. So the repetition for series x, the repetition value will be calculated as 1 by 12 bracket 3 square minus 3. This is for repetitions in series x plus. Now we will put the effect of repetitions in series y with the same factor, that is 1 by 12 m cube minus m. Now how many repetitions are there in series y? There is only one repetition, and that is value 38. How many repetitions are there? 3 repetitions are there. So the value of m is again 3. So what will be the repetition factor for series y? It will be 1 by 12 3 cube minus 3, same as that of x. We are going to add these factors to the formula like this. Just see the change in the formula which is there on the screen. The formula is now r is equal to 1 minus 6 bracket starts summation d square as it was in the previous formula plus t. T is that factor of repetition which you have calculated just now. It is a combined effect of repetition. As many number of ranks which are repeating, you are going to put that t as an addition to d square. The denominator remains same as n into bracket n square minus 1. Here in this question we have one repetition in series x and one repetition in series y. So our value of t will be 1 by 12 for series x bracket 3 cube minus 3 plus 1 repetition in series y, again 1 by 12 bracket 3 cube minus 3. The value is coming out to be 4. Now after calculating all the required values, let's put the values in the formula. Spearman's correlation coefficient will now be equal to 1 minus 6 summation d square, the value is 28, plus t, the value which we have calculated is 4, 28 plus 4 in the bracket, divided by, there are 10 pair of values, so 10 bracket 10 square minus 1. The value of correlation coefficient here is coming out to be 0.81 positive. So this indicates that there is a strong positive correlation between the two variables x and y. So students, that is all with the fundamentals of correlation analysis. Correlation analysis is a very essential tool in financial and business analysis for taking well-informed decisions. Thank you.